Okay, our new unit is on logarithmic functions, which is a gigantic word, so we often call it log. You have seen this button on your calculator. Look at your calculator. Do you see the button that says log? That's the button we're going to learn to use. So before we really jump in to the craziness of logs, we're just going to take them at their most basic level and really get to understand how beautifully simple they really are. So you should have a sheet in front of you that looks like this. If you don't have that, so be it. You can just use your own paper. So we're going to talk about logs. But before we talk about logs, we are going to talk about exponential functions, because logs and exponentials are basically the same thing. So what do we know? We know that if I've got 2 squared, it equals 4. And if I have 2 cubed, it equals 8. So these are pretty basic things. So let's first make sure we know the parts of this. The 2 is our base. The 3 is the exponent. And then we've got 8, which is our answer, right? So what if we wanted to know something in between? In between 4 and 8 is 6, right? So what if I wanted to use my same base, 2, and I wanted to know 2 to the what would give me 6? So this is where a log comes in. A log untangles exponents. All right, it's going to untangle the exponent. It can undo them. We can figure out what exponent we would need, because think about this. If we've got 4 and we've got 8, somewhere in between is 6. So if we've got 2 as an exponent and 3, stands to reason that this exponent needs to be in between 2 and 3. Is it 2.4? Is it 2.65? We don't know, but this is what a log is going to help us do. So let's kind of look at this. So we just said that if we have a base to an exponent, it gives us an answer, right? So let's put some accurate variables on that. We would usually call our base a, and we would say a to the y equals x. All right, so this is our exponent form. This is exponential. Now, I know what you're thinking, or I hope you're thinking. I think you're like, good bit, why isn't the exponent the x? Haha, I will tell you that soon. So, but it's not. I've reversed it. And what happens when we reverse things like that? When we flip our x and y, what does that make it? Think about it. Okay, so if our exponent is a to the y equals x, then we are going to reverse this and undo it. And that's going to give us what we call a log function. And a log function looks like this. Log base a of x equals y. So notice this for me. Just like we said a second ago, it finds the exponent. Remember that question mark we were looking for? It's going to give us the exponent. The answer is the missing exponent. Okay? Do we need to write that down? It finds the missing exponent. Exponent. Okay. That's what it does. So, logs untangle exponents. So let me give you an example. So let's say we have 2 to the 4th. All right, well, 2 to the 4th is 16. So that's the exponential format. It's written with an exponent. If I want to reverse this and put this into my logarithmic format, I am going to undo that. So my a, look where we had this. Our a was our base. So what's my base here? 2. And that's going to become this little base next to the word log. So I'm going to write log base 2. All right? Of y. Well, y, we already know in this case, remember y was, we had in blue, was this 4. So that's going to become my answer. So my answer is going to be equals 4. And the x was the answer of my exponent and is now what the log what I'm taking here. So this is going to be 16. So I would read this, log base 2 of 16 equals 4. Okay, so we read this. Let's write down how we read this. We read this. We're going to say log base 2 of 16 is 4. Okay, so and make sure you write this 2 really small. It's a subscript. You know, like when we write H2O and you write that 2 really small, that's what's happening with the base and the log. Okay, let's look at another one. What if we have, let's just talk about an exponential we know. How about 3 squared? 3 squared equals 9. So if I want to put that in log format, I'm going to say log, and my base is 3 of 9 equals what? Remember, we're looking for the exponent. What's the exponent that gives us 9? And it's 2. So log base 3 of 9 equals 2. What if we go backwards? What if I tell you the log base 7 of 343 is 3? How do I undo that into my exponential form? Well, my base stays my base. And remember, our answer is the exponent. So 7 cubed equals 343. Okay, so 7 cubed equals 343. And that is equal to the log base 343 equals 3. All right, what if we get a little bit wild here? What if we do, oh, I got a good one for you. Let's look at what happens when we've got zeros. 8 to the 0 equals what? 1, right? Anything to the 0 is 1. How do we rewrite that as log? So we're going to have log base 8 of 1 equals, remember we're looking for an exponent, equals 0. See, it looks a little funny when it's like an unexpected exponent. Okay, how about this? If we have 16 to the half, 16 to the half, well, what is 16 to the half? Remember, 16 to the half is the same as having the square root of 16, which is 4. Okay, so log format. Log base 16, our base here is 16, of 4 equals, what was the exponent? The exponent was half. So log base 16 of 4 equals half. Okay, one other that looks a little bit funny. What about negative exponents? Like what if we have 5 to the negative 2? Well, 5 to the negative 2 is the same as 1 over 25. Okay, put that in log format. Log base 5 of 1/25 equals negative 2. Okay, so as a quick recap, all that's happening with log functions is we are untangling or undoing an exponential. All right, you'll notice we have no x's here yet. That's fine. We need to get used to the format. So when we rewrite it, the base becomes a subscript. The exponent is our answer. And really, the reason we're doing this is because logs are inverses of exponentials. That's all that's happening, is that we're learning how to find a missing exponent. That's our whole goal, is to find a missing exponent. Okay, try a few yourself.